Hello everyone, welcome to today's class. Welcome. We'll be starting in a minute. We are continuing with our class on circle theorems. Okay, so I just want to add the students from the WhatsApp group and then we're going to start immediately. Circle theorems. So in the previous class, we looked at the different circle theorems. So what we are going to do today is we are going to focus on solving questions. Okay. We're going to focus on solving questions on circle theorems. So just a minute, just want to send the link to the students in the WhatsApp group. Okay. So let's start. Let's look at our first example for today. So let's if you're just joining, welcome. Please, I'm trying to bring out the questions. Let's look at the first example we have here. So we're expected to find the value of x in. So if you're just joining this particular lecture for the first time, that means you need to go back to our previous lesson and so that you can see what we did on circle theorems. Okay, because if you don't have that foundation, you will not be able to follow us on this journey. So even though you're joining us, you still need to go back to watch that lesson. So we're looking for x. This angle here is 78 degrees. Okay, so we need to find the value of x using the circle theorems that we have already learned. Good evening, everyone who just joined. Richmond, I can see you. Marcia, I can see you. Epistle, it seems you're here for the first time. Okay, so it's not a perfect circle because I'm not here to draw a perfect circle. I'm here to do a calculation. Okay, so let's continue. So this is a circle, right? And you have a center here. You have a tangent touching this circle at this point. So we're expected to find the value of x. So we're expected to use one or more principles that we learned from our previous class on circle theorems in order to find this value of x. So if you were part of the class last time, I'd like to know how do you think, what principle do you think we can use to find the value of x? And remember, you don't have to use one principle. What I mean is that someone else might use a particular principle to arrive at a particular answer, and another person might use another set of rules to arrive at the same answer. Okay, so the most important thing is arriving at the correct answer. because you can use more than one principle to arrive at the correct answer. So if you were part of the class, if you are part of the previous class, I would like you to let me know what principle do you think we can use to find the value of x. So I'll just give 1 minute. If nobody can tell us, then I go ahead to solve. Remember, those that were in the class, I think Richmond was in the class, Marcia was in the class, Chidera was in the class. I'm sure of that. So what principles do you guys think we should use? You can flip through your notes. Okay, nobody is coming up with an answer. So let's look at it. Let's look at it. One of the principles we learned in our last class is alternate segment theorem. Alternate segment theorem. Okay. We looked at alternate segment theorem. Correct. Good. So looking at alternate segment theorem, we saw that the angle that is created by a tangent and a chord is equal to the angle that the chord creates with the circumference. So this chord creates an angle with the circumference. That angle is equal to the angle created by the tangent and that chord. So just by using that principle, you've gotten the answer. So by using this principle, our answer x is equal to 78 degrees. You can state the reason: alternate segment theorem. Very easy. So just by understanding, Francis, nice to see you. Good evening. So just by understanding that principle, Gilbert, nice to see you. Good evening. Are you from the WhatsApp group? So just by observing that principle, you have gotten the answer. But let's see if you can get the answer using another means. Remember, I told you you can use more than one way to get the correct answer. Now, we know that this from 0 to the circumference is a radius. We learned that one of the principles is the angle that is formed by a tangent and the radius is equal to 90 degrees. That means this entire angle is equal to 90 degrees. That entire angle is equal to 90 degrees, right? So if this entire angle is equal to 90 degrees, if you subtract 78 from 90 degrees, you are going to get 12 degrees. This is a longer method, but we are still going to get the same answer. So this angle that is formed by the tangent and the radius is equal to 90 degrees. So when you subtract 78 degrees from 90 degrees, you're going to get 12 degrees. And another principle we learned is angle in a semicircle is equal to 90 degrees. So if you look here, this diameter cuts this circle into two equal parts. So this is a semicircle, this is a semicircle. That means, is the network bad? It seems from my end that the network is bad. From this phone in front of me, it seems the network is poor. Mustafa, nice to see you. Okay, so this angle here, since this is a semicircle, this angle is equal to 90 degrees. So we know here to be 90 degrees, we know here to be 12 degrees. Sorry about that. If it continues to be bad, then we might just postpone the class to another day. But let's see how it continues. So 90 plus 12 gives you 102. You know that sum of angles in a triangle is equal to 180 degrees. So 180 minus, you're still going to get 78 degrees. But this method we use is longer than the first method we use, okay? So we went round and round and round to arrive at the correct answer. But just using alternate segment theorem from the first method, we were able to get the correct answer. So 78, 78, using alternate segment theorem. Okay? So if you are not catching up, it's because you have not gone through the previous lesson we learned on circle theorems. Okay? So you need to watch that to have a better understanding of what we are doing. So we're going to solve another question. We're going to solve another question. I hope you guys are done with this. Okay, let me get another question. So I'm wiping this off. So today what we are focusing on is just examples, examples, examples. Yeah, this is not a perfect circle because spending time to draw a perfect circle is not the focus of this class. And I'm not an artist. So that's not the focus of the class. Okay, so let's look at this question. Might not be a perfect drawing, but let's look at it. So we're expected to find this angle, angle X. These questions are very easy if you have been following all the topics we have been looking at. In one of our previous lessons, hello Daniel, nice to see you. In one of our previous lessons, we looked at types of triangles, okay? I think I missed something. Let's see what I missed. Yeah, 40 degrees. So if you are expected to find X, let's see the principles that we're going to use. First thing, observing here, we discover that this is the center of this circle, right? That's the first thing we observe. The next thing we observe is that this small triangle here is an isosceles triangle. An isosceles triangle is a triangle. Hello, Humble, nice to see you. Good evening. An isosceles triangle is a triangle that has two sides equal. So these two sides are equal. So since those two sides are equal, that means the two angles facing them will also be equal. So these two angles are equal. So let's call both of them angle Y, because it's an isosceles triangle. And since it's an isosceles triangle, both angles are equal. So we are trying to find the value of X. Getting the value of X is very easy because if we follow alternate segment theorem, we know that this angle is equal to this angle. Does anybody agree with that? If you agree, say yes. If you don't agree, say no. X and this angle, they are equal using alternate segment theorem. Angle that a tangent forms with a chord is equal to the angle the chord forms with the circumference. So this is the angle the chord forms with the circumference. Okay? So these two angles are equal. But we don't know this angle, but we can find that angle because we know that this is an isosceles triangle. So those two sides are equal. So we can simply say 2y plus 40 degrees is equal to 180 degrees. 2y is equal to 180 degrees minus 40 degrees. 2y is equal to 140 degrees. So if we divide both sides by y, correct, Richmond. If we divide both sides by 2, y is equal to 70 degrees. So we've gotten the value of y. So since we know that x is equal to y plus 10, so x is equal to y plus 10 degrees. And now y is equal to 70 degrees, x is equal to 70 degrees plus 10 degrees. X is equal to 80 degrees. So that gives us, I guess we are talking about y. Y is equal to 70. But finally, x is equal to both of them combined. Both of them combined. So someone else might decide to go another route, which is longer, and decide to find the value of the angle at C. Angle at the center is equal to twice the angle at the circumference. You say this one is 20 degrees, and you begin to look for more angles. You will finally arrive at the same answer, but it will take you a longer time, which is not necessary. Okay. So I'll leave this on the board for 1 minute, and then we'll look at another example. So I think we have 2 more classes for this month, and then we're going to see how we're going to reduce the number of students in the group. The crowd is too much, so I just want to reduce it so I can get to interact with you guys. If I know the number of persons in the group, I can end up leaving the group open for you guys to interact. But having over 900 persons in a group, it will be chaotic to allow people to be interacting whatever they want to say. Okay, so now let's look at another example. Let's see. Do we have another example? Yeah. So now we'll try to, let's not find x again. We've been looking for x. Let's look for another alphabet. Let's look for C. Let's look for C. I'm going to leave the question on the board for 2 minutes to see if anybody can get the answer before I solve. Be careful. Be careful. Okay. So we are looking for C in this question. I'd like to see who can give us the correct answer in 3 minutes. Because if you know the principle to use, it's not going to take you more than 3 minutes to solve. If you know the exact principle to use, it's not going to. Some persons are getting 70 degrees. Is that the value for C? or your final answer. I mean the previous question. I'm seeing value of the answer x equal to 70 degrees. Hope that's not the final answer. Okay, so hope you guys are trying to find the value of c here. Hope you're trying to find the value of c. Two minutes more. The network is pretty poor. 2 minutes more. This is 64 degrees, by the way. 64 degrees. No one has gotten an answer yet. 1 minute more. Okay. Richmond said 40 degrees. Okay. Let's see how it goes. Let's see how it goes. What principles did you use? What principles did you use? What principles did you use? Okay. Paul said 26 degrees. Okay. That seems more like it. That seems more like it. That seems more like it. I will just label this A, B, C for easy identification. Semicircle equal 90 degrees, okay? That's true. That's true. That's true. Humble got 64 degrees. What principle did you use to get that? Okay, let's look at it. Let's look at it together. So first, we can see that triangle ABC is inside a semicircle. Triangle ABC is inside a semicircle because this line AC is a diameter. So a diameter divides the line Chidera, okay, 26. Angle at the circumference is twice angle at the center. Your answer seems to be correct, but the principle seems to be wrong. But let's look at it. Probably you made that method you used. So triangle ABC is in a semicircle. This is a semicircle. The reason it's a semicircle is because AC is a diameter. Okay. So since this triangle is in a semicircle, we can say that angle ABC, this angle at B, the entire angle at B, which includes this angle, let's call this angle X. I like X. So this angle at B includes X and C. So angle at B is equal to 90 degrees. Angle in a semicircle, right? So the entire angle at B is equal to 90 degrees. But this 90 degrees is made up of X and C. So, but now, if you look at this angle here, we have 64 degrees. This from 0 to A from 0 to A is a radius. From 0 to B is a radius. Remember, a radius is a line drawn from the center of the circle to any part of the circumference. So D from 0 to A is a radius. From 0 to B is a radius. Therefore, we can say that they are both equal. So since they are both equal, that means the angles facing them are also equal. So we can say that angle X is equal to 64 degrees. Angle X is equal to 64 degrees. So now, since we know that angle X is equal to 64 degrees, and we know that X plus C is equal to 90 degrees, so X plus C is equal to 90 degrees. That means C is equal to 90 degrees minus 64 degrees, which gives us 26 degrees. So that's why the Marcian is correct. So that's the reason C is equal to 26 degrees. Okay. If you look at it another way, you still get 26 degrees. So since these two angles are the same, this angle is 180 minus 128, which gives us 52 degrees. This angle here is just a long way, which is unnecessary. This angle here is 180 minus 54 degrees, which is 128 degrees. Also, these two sides are radius. So if you do 180 minus 128 and you divide it by 2, you still get 26 degrees. Okay? So the answer is 26 degrees. If you're experiencing poor network, please, I'm sorry about that. Seems the network is bad today. Okay, so let's see another example. So this question involves a cyclic quadrilateral. Remember, a cyclic quadrilateral is a quadrilateral that's inside a circle. But you might not need to use that principle. Be observant to see the principle you need to use. Okay. Looking at this question, you guys should try it out using any of the principles that we've learned. Try it out. Answer to the previous one was 26 degrees. The previous answer was 26 degrees. seems I might have to do this class again next time because the network from, okay, Gilbert got 59 degrees. Okay, so x is equal to 59 degrees. That's a good one. Yeah, I guess you were right. Chidera said the network is poor. I'm thinking I should repeat the class. I'm thinking I should repeat the class. But if I have to repeat the class, I have to look for new examples. I think that's why probably we have few in attendance in today's class because the network is poor. It rained over here today. So I don't know. Nigerian network, once it rains, the network gets bad. I'm even thinking about doing recorded lessons where it might not be live, but I prefer the live class because it's more interactive. But if the network is always bad, then I have to do recorded classes, then upload it, and then let you guys watch it whenever you're available. If the network continues to be bad. So hope you guys are attempting the question. One person has said 59 degrees. Okay, Francis also said 59 degrees. We hope so. We hope so. Marcia, 59 degrees. Okay. I haven't solved it, so it's not looking as if it's going to be 59 degrees, but let's see. So 1 minute more, then I solve. Okay. Biko Charles said 59 degrees. Okay. Thirty seconds more. 30 seconds more. Okay. Daniel also said 59 degrees. Let's confirm. Let's confirm. So first thing we do is we observe that line DC is a diameter. Therefore, this is a semicircle and this is a semicircle. Okay. So we also observe that angle in a semicircle is equal to 90 degrees. So this angle coming up from this point and this point, producing this angle here is 90 degrees. So if this angle is 90 degrees, if we consider triangle ACD, triangle ACD, angle at D will be equal to 180 minus 90 plus 18. So this angle will be equal to 180 minus 118, which is 62 degrees, I guess. So this angle here is 62 degrees. That angle there is 62 degrees. So when we looked at cyclic quadrilateral, we said opposite angles sum up to 180 degrees. That means angle at D plus angle at B is equal to 180 degrees. And we know D is equal to 62 degrees. Angle at D is equal to 62 degrees. That means B is equal to 180 degrees minus 62 degrees. 180 degrees minus 62 degrees gives us 118 degrees. So this angle here is 118 degrees. Yeah, the network is so bad. Can you guys even see what's on the board? Okay, network is so bad. So this angle at B is 118 degrees. So this is 118 degrees. So this angle plus this angle gives us 180 degrees. So x plus 118 degrees plus 31 degrees is equal to 180 degrees. X is equal to 180 degrees minus 118 plus 31 is equal to 149 degrees. So it's either I got the answer wrong or you guys got the answer wrong. So x is equal to 31 degrees. So if I made a mistake, let me know. Did I skip something? Oh, I skipped something. This is supposed to be 108. So if this is 108, this will be 72 degrees, right? And then if this is 72 degrees, it will be 108 degrees. And if this is 108 degrees, this will be 139 degrees. And then this will be 41 degrees. So that should be the answer. 41 degrees. 41 degrees. Who is correct? No, Richmond, I don't think you're correct. You said 49 degrees. So just look at what I solved. Look at what I solved. So the first thing we considered is triangle ACD, and then we observed to find the angle here. There was no angle here, so we observed to find it. We know that this angle is 90 degrees because angle in a semicircle is equal to 90 degrees. So we got that. So 90 plus 18, and then you subtract from 180 gives you 72 degrees. That means this angle here is 70 degrees. So this angle plus this angle should give you 180 degrees. Should give you 180 degrees. So 72 degrees, 180 degrees minus 72 degrees gave us this angle to be 180 degrees. That's what we got here. And then when you add these two angles and subtract them from 180 degrees, you are going to get the value of x. Okay, okay, you wrote 41 in your book. Okay, so that gives us the answer to that question. Yeah, it's a cyclic quadrilateral. The shape is a cyclic quadrilateral, and that's why we used opposite angles of a cyclic quadrilateral sum up to 180 degrees, because it's a cyclic quadrilateral. All the points are touching the circumference. You mean, Marcia, another one on cyclic quadrilateral? Another question on cyclic quadrilateral? Let me see if I have another question on cyclic quadrilateral. Um, On my list of questions, I don't have another one on cyclic quadrilateral. Sorry about the poor network today. I don't have another question on cyclic quadrilateral. Um, I'll suggest that we just end the live class because it's quite, the network is really poor. Probably we'll fix another date to solve more questions on cyclic quadrilateral. We'll fix another date. Okay. I'm even struggling with the network over here because I can't really see clearly what's on my screen, the screen in front of me. Let's see if we can solve one more question. Let's see. So we're expected to find the value of x. Uh, I'd like you guys to try it out in 2 minutes, and then let's see what the answer will be. Try it out in 2 minutes. Yeah, the network is very bad. Very bad. Paul, are you part of the WhatsApp group? Let's conclude with this question. Let's find the value of x in this particular question. This is quite easy actually. It's quite easy. You should be able to do it in, if you are conversant with the principles we learned, you should be able to do this in 3 minutes. What 3 minutes is even long? In 2 minutes. Okay, nice. Okay, 50 degrees. Great. We are going to confirm. Uh, Richmond said 50 degrees. Okay. I'd like you to check again. Check again if you omitted something or you are too fast. Check. 50 degrees seems very close to the answer, but I don't think it's the answer. $40. Okay. What principle did you use? What principle did you use? Oh. Let's see. 40 degrees. Angle at the circumference is twice angle at the center. Angle at the circumference is twice angle at the center. Hmm. Your answer might be right. Your answer might be right. Who gave that answer? Let me scroll up. Did the person delete the answer? I think it was Chidera that did that, that sent the message. You got 54, okay. Isosceles triangle, isosceles triangle. Okay. Yeah, you can use isosceles triangle, but will you get 50? The part you said isosceles triangle, correct? But will you get 50 if you do that? The value of x, will it be 50? 1 minute more. Okay, correct? Okay, let's look at it. Let's look at it. So from this point, this is the center. So a line drawn, correct, Marcia? A line drawn from the center to the circumference is called radius. So here to here is a radius, here to here is a radius. So both of them are the same. So that means they are equal. And if both of them are equal, that means these two angles are also equal. So let's call here y, and let's call here y. So 2y plus 80 degrees is equal to 180 degrees. Angle, sum of angles in a triangle. 2y is equal to 180 degrees minus 80 degrees. 2y equal to 100 degrees. Y is equal to 50 degrees. So this angle here is equal to 50 degrees. But the point where a radius and a tangent meet, they form a 90 degrees. So that means x plus y is equal to 90 degrees. X plus 50 degrees is equal to 90 degrees. X is equal to 90 degrees minus 50 degrees. X is equal to, Humble said 130. X is equal to 40 degrees. That gives us the answer to the question. Okay? That's the answer to the question. So sorry about the network today. So sorry. Um, that's how it is over here. It's quite bad. We hope that next class it will be better. Okay, so that solving that question brings us to the end of today's class. Sorry we have to end early because it's really stressful working with a poor network. It's really stressful. I don't enjoy the way I should have. I should have enjoyed it. Okay, so we continue our class on Wednesday. We'll let you guys know the topic that we'll be learning on Wednesday. Okay, I'll let you guys know. But if you add all the angles, you wouldn't get 180. Where? Here. 50 plus 50 plus 80 is 180 degrees. Remember why? Why there are 50 degrees. So 50 plus 50 plus 80 is 180 degrees. X is outside. It's not inside this triangle. X is outside the triangle. So y, the two y values are inside the triangle. Can't we use all? Are you trying to say can't we use alternate segment theorem? I no, we can't use, if that is what you're saying, we can't use alternate segment theorem. because for us to use it, this angle would be at the circumference. The angle has to be at the circumference, not the time you can use it is when the angle is at the circumference, not at the center. Okay. So thank you guys for being here. Uh, Despite the network, I really enjoy the class. You can't hear me well. Um, just if you're just joining, just try and watch the video again. Jonathan, good evening, Freddie. Nice to see you. You're just joining when we're about leaving. We're about leaving the class. Good evening, James. You guys that are just joining the class, you can just, do you have a question for us? You're saying one more question. Do you have a question for us to solve? Even if you have, you might not be able to send it to me right now. I don't think I have one more question to solve. I don't think so. But if you have any question that you want me to solve, you can send it to me. Then I'll solve it. I'll solve it. Make a video of it, and then post it on YouTube so you can see it. Yeah, I just have to go, guys. Just have to go. If it were possible for you to send me a question right now for me to solve, I would have done that. But I have to go. Let's see if I can see a question. Let's see. Okay, one more question. So we're still finding the value of x. Imperfect circle. Okay, so this is the last question for today. To find the value of x. So you guys should try this question in 3 minutes. Then we'll solve it together. Okay. This question is quite easy though. You should be able to finish it in. Once you understand the principles, no matter how complex the question looks, once you apply the principles, you'll get the answer. Has anybody gotten the answer yet? Really, 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 really easy. Very easy. Okay, Marcia got 74 degrees. Okay, that's a good attempt. That's a good attempt. Once you get this angle right, you get the answer. Once you get this angle right, it's easier for you to get the answer. If you get this angle wrong, you miss the answer. Humble also got 74 degrees. Richmond got 37 degrees. Okay. So those of you that got 74 degrees, check. This angle looks too small to be 74 degrees. X looks so small for it to be 74 degrees. Okay, let's see it. Because my time is up. I have tutoring in the next 12 minutes. Okay, so if you look at this point, a radius is meeting a tangent. That means this angle here is 90 degrees. So if this angle here is 90 degrees, this angle here is 90 plus 32 is 122. 180 minus 122 is going to give us 58 degrees. So here we have 58 degrees. Okay. So using angles on a sum of angles on a straight line, using sum of angles on a straight line, if here is 58 degrees, here will be 180 minus 58 degrees because the sum of angles on a straight line. That's why we needed to learn about sum of angles on a straight line, sum of angles in a triangle, because that knowledge forms a foundation for further topics. So here is 180 minus 58, which gives us 122. 122 degrees. So you can, for you to have good understanding, you can watch the previous lesson and then watch this lesson again. You will now be able to join them together and see what you're doing. Okay, so if here is 122, remember this side and this side yours. So they are equal. So since they are equal, these two angles are equal. So we have 180 degrees minus 122 degrees, which gives us 58 degrees. But that's not the answer. These two angles are equal, so we divide 58 degrees by 2, which gives us 29 degrees. That is the answer. So take our time to go through it again to have a clear understanding. 29 degrees each. So this angle here is 29 degrees. Yeah, 29 degrees. So when you are solving questions like this, you don't need to be in a hurry. Ask yourself what principles are available here. What principles are available here? And you move from the known to the unknown. You cannot start from here because there is nothing that can help you start from here at the beginning. So you move this way, from what you know to where you don't know. Okay, that should be all for today. So we'll continue on Wednesday. I need to prepare for my next class. Have a wonderful evening. See you on Wednesday. Okay, good. See you on Wednesday, guys. Good night. For Marcia, I think it's good afternoon. So good afternoon.